Hello and welcome open source enthusiasts. I'm Hichem, the product architect at NetApp, and I'm really excited today to be presenting you with the latest addition to our open source managed platform, ClickHouse. What is ClickHouse? ClickHouse is an amazing open source columnar-oriented database management system designed for OLAP, online analytical processing. It offers several key advantages in the OLAP world, but it also has expanded its capabilities to support vector operations, enable it to handle vector and semantic search tasks without requiring additional infrastructure. Let's make a point here. It's not a vector database, but it's certainly a good option if you're looking to combine semantic search and metadata with standard SQL. In this video, we're going to learn how to perform vector search with Instaclustr Managed ClickHouse. So at Instaclustr, we address many of the major challenges with open source in general, and ClickHouse in particular, the complexity in setup and maintenance. We ensure optimal performance, configuration, monitoring, and tuning with a dedicated team of experts to manage it all. Before we jump in, if you're new to Instaclustr, you can start by creating an account. You can find all the information. Once you have your account, you can use the console to create a ClickHouse managed cluster under the free trial period, which is available only in AWS for now. You can also see the set of all open source frameworks and databases solution that we offer as a managed service. You will also find more information and guided steps in our documentation, specifically if you want to spin up a ClickHouse instance. So as I said, either using the console, but you can also perform this using our API or Terraform. Keep in mind that our platform is fully secured and isolated by design, so please read through to find out more on how to deal with security and network configuration. Now, we also need a SQL editor for performing all SQL queries, so I would strongly recommend dbeaver. It has a community version, and in few steps you can connect it to your freshly created Instaclustr Managed ClickHouse. All the guides and the documentation will be linked in the video description. Now we are all set to start exploring ClickHouse capabilities in the vector search world. The key concept here is the vector embedding. What do we mean with this? Embeddings in machine learning are generated by training a model to convert input data into numerical vectors that capture the essential features and relationship of the data. They can represent objects like words, images, or documents in a continuous vector space. This is an overall simplification, so I recommend that you read through different resources to learn more. Thanks to a vibrant community and ecosystem, companies like Cohere have created embeddings for Wikipedia articles and made them available free to use in a Hugging Face dataset. With a closer look here to these embeddings, your dataset, you can see the original the original Wikipedia page, as well as some metadata like URL, the number of views, and finally the embedding themselves here, when you can see it's like a 768 float arrays. Using other functionalities from Hugging Face, and especially the autoconvert, we will use these Sparky files to insert our data in the table we'll create soon. Cohere has this great blog describing how they created these embeddings, how they broke down these packages from Wikipedia articles into embedding vectors. It's really worth reading if you want to understand the generation process. In order to convert the input phrase or text that we will be using into a vector to compare it with the Wikipedia embedding from Cohere, we will need to use the Cohere API to use their multilingual model to generate this embedding. This is a free trial key, obviously, because we are using this for a non-commercial purpose for this video. So you will find all this code and the detailed explanation in my blog, covering the same topic with more details with the same examples based on the data exploration. So either you use it using the Hugging Face dataset explorer or ClickHouse. You can use it describe to infer the schema. We can proceed to create our source data table, starting with a merge tree table engine, and then inserting the data from the Sparky file. We will use the URL to read the Sparky files, insert them into our created table. Please check again the blog for more exploration. Now comes the exciting part. Utilizing these vectors to find the most relevant response to a given search or an input phrase. The first thing to note here, this is a simple and familiar SQL. So there is no need to learn any new sophisticated language or queries. So we have in total more than 500,000 rows or embeddings in this case in our table, and we will calculate the distance and sort them by the distance and return this result with the minimum value for the distance. And by the way, you notice here that in ClickHouse, vectors are just arrays of 32 floating points. We will use two different approaches here, or functions to be more precise. Similarity metrics, the L2 distance, which is the Euclidean distance, and the cosine distance. It's a mysterious at this point what is the input phrase, but if we run it here, let's run it and see the results. Take a few seconds, because by the way, we didn't do any kind of tuning. This is straightforward. We didn't do anything to optimize our queries. And you will see here, we will end up with this amazing scientific figures and technology creators. We got the top 5. Now let's try cosine distance, which is, in this case, we get on the same embeddings, by the way, we will get pretty much similar results. So we get similar, but with more relevant results here. And now, if we look at the Python code that I used to generate the embedding from the Cohere API, you can see, voila, that was the input text, who created Unix. And obviously, we've seen in the results here, Linux kernel and Linus Torvalds. So to summarize, we have kept things really simple using basic default choices, free trial account, and this approach allows us already to establish a functional baseline, which we can then refine and optimize once we gain more insight into our data and performance requirement. Please check the full blog again if you want to learn more, and I would love to hear from you. Thank you, and please subscribe if you want to get more open source content.